Okay, so I think we've waited just about as long as we can. What's up, everybody? I'm Matt. Welcome to Business Calc 144. Yeah, that is all I have for a hello. How are y'all?
Good.
Good? Awesome. So today I thought we'd go over the syllabus a little bit. Just a couple breakdowns, some things to point out about the syllabus, and just a couple things to point out about Blackboard. First question, office hours. I don't have them yet. It'll probably be later this week that I'll have my office hours. I'll have to have them submitted to the department by Monday. So they'll certainly be done by the end of this week. There's been a lot of questions about how exams will be given. I've decided that I'm going to give exams over WebAssign. And the way I'm going to do this is I'm going to use a browser lock feature on WebAssign. And everyone's going to have about an hour, 15 minutes to get it done. Having said that, breakdown of grades, because that's always important. The way my grades are broken down on the syllabus on the third page, at the very bottom of it, we have 20% going to the final, 40% going to exams, and then another 40% going to homework. Within that homework grade will be attendance, which a question of the week will be part of, and I'll explain that in just a second. You have 4 exams, so 10% of your grade will be each exam, approximately, right? The question of the week, the way this attendance idea is going to work is every week I'm going to post a question of the week. Go figure, right? And what it really is just a litmus test to see how everyone is getting the material, right? I don't grade it for correctness. I just grade it to see if you did it. So this is your opportunity to be like, yo, I don't know how to do it. That said, it's going to be through Blackboard. There's a question of the week tab. I think I labeled it QOTW. And you just click on it. There'll be a discussion. It'll say week whatever. And then you just post within that your answer. I am probably going to post one this week just to kind of get us familiar with the process, the idea of it, and to debug any problems that we have this week, right? Having said that, since they are going to be used for attendance, the way this is going to work out is the question of the week will count for about 12.5% of your homework grade. So that's roughly 5% of your total overall grade. Now, the reason why I'm putting this in your homework grade was because I didn't think to actually separate it out in your syllabi. So that's the reason why I'm presenting it this way. Overall, it's 5% of your grade, but it's going to be 12.5% of your homework grade when you look on Blackboard to get your grades. Since I can't hook up my laptop right now, I can't give you all a walkthrough of Blackboard and everything that's on it. But I can tell you all that on Blackboard, I have posted supplemental books, supplemental lecture videos. So if there's a question that you'll have or something that wasn't clear, don't wait on me to respond to emails, right? Like give me 24 hours to respond to an email. But if it's something that needs to be answered right there and then, you're all gonna have to do some footwork here. This is just part of the learning process, right? Like you can't, if you don't know the answer, you can't reach your instructor as fast as you'd like. You need to figure out how to go about finding this information on your own. To help facilitate that, you have these supplemental textbooks and supplemental lecture videos. Having said that, there are also 2 tabs for review material, one over algebra and one over trig. And all those are my old lecture notes and my old study guides. which will give you a decent idea of what my study guide will look like in this class. There's a course material tab, which will have exactly that, all the material for this course. Within it already, there is a document, a PDF that goes over a bunch of math jargon and math notation. There's a PDF that explains what all of your resources are. And then the syllabus. I've also created within that folders that I'm going to be populating with PowerPoints and study guides for each exam. So you've got exam 1, 2, 3, and 4. Other than that, as far as how to reach me for office hours, once they're announced, the same link that you click on for the live lectures will be the same link you click on for office hours. There's also a past lecture tab that will take you to YouTube, where I'm going to post all the lecture videos. So if you're sick or if you miss a video, you can click on it and just catch up what you missed. Having said that, is there anything else I need to cover? Let's see. Anything else on Blackboard? There we go. Oh, homework tab, obviously. Homework is going to be through WebAssign. You just click the homework tab, it'll take you there. There's already a homework posted for this week. So anybody expecting to watch the Super Bowl this weekend, I'm sorry, you have homework this weekend, or throughout the week, preferably throughout the week. There are 30 problems already for this homework. It's largely review material from algebra. So go ahead and get started on it. Most of it, I suspect y'all will be able to do without me lecturing on it, right? Because like I said, it's right now we're just going to go over review for this first week. What else? That's everything. Dope. Awesome. In that case, let's get to our first lecture. So today's lecture is going to be pretty quick and simple, actually. I'm just going to cover the first section of the book, section 1.1, which is really just over the basics of graphing things, the Cartesian plane, distance, and midpoint. So not a whole lot of meat here, just some preliminary stuff to get us moving towards. All right, so start off with, let me ask a question. What is the Cartesian plane? Does anybody know? Anybody know? No. So the Cartesian plane is something we're actually all familiar with. It just has a technical name. The Cartesian plane is our traditional XY graph. Mathematicians like to be extra, so we call it the Cartesian plane. Can you all see that?
Yeah.
Yeah? Awesome. So, as most of us, I suspect, already know, the Cartesian plane has an x-axis and a y-axis. And an origin point. And then we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. So a note on these quadrants. The quadrants are all the points that sit between our axes, right? So quadrant 1 is only everything up to the y-axis and up to the x-axis, but not including the axis itself, right? Having said all of this, this is all well and good, but it doesn't do anything for us if we don't know how to actually use it, right? Like, great, we know what the Cartesian plane is. We know its anatomy, but how do we use it? In particular, if I wanted to throw a point on here, how would I do that? Like, what would that look like? How would everything work out? Well, let's imagine we do have a point. We have a point 1, 2, and we want to throw it onto the Cartesian plane. What this ordered pair tells us is that the point has an x position and a y position. So to plot it accordingly, we would move 1 unit over in the x position, or in the x-axis, and 2 units up in the y-axis to find our particular point. So let's say it's looks something like this. To plot that point 1, 2, we would go to 1 unit over in x, 2 unit up in y, and it would be this point right here. Well, looking at this, we can already see a little bit that this can get messy really fast. What if I had like 5 or 6 points that I wanted to throw up here? I don't want to keep labeling it with their ordered pairs, right? So sometimes mathematicians will title a point something like this, right? P, Q, S, whatever. And we'll just write in that title for the point instead of actually writing out the coordinate system itself. I mean, the coordinate, the ordered pair. That's all I had on Cartesian plane for that part. Having said that, let's say then that we had a bunch of points representing some data. In particular, let's imagine we have a bunch of data representing the height of an object with respect to time. This data looks something like this. TH, at time 0, we have a height of 16. Time 1, 2, 3, and 4. At time 1, the height is 8. At time 2, the height is 4. At time 3, the height is 2. And at time 4, the height is 1. Now we want to plot these on the Cartesian plane. The first thing we're going to want to do is notice that we don't necessarily need all of our negative values, right? So we can truncate our graph a great bit. Instead of writing out all of these extra quadrants, which we don't need in this case, we can just go ahead and truncate our graph and start from here. Now we need to designate which axis is going to represent which variable. Usually, mathematicians, we like to use time in our x-axis. In this case, height in our y-axis. From here, we want to know what our unit values are going to be. We want to kind of get an idea of where 0, 1, so forth and so on will lie along the x-axis. And similarly, we're going to want to do the same thing with our y-axis. In this case, we're going from 1 to 16, right? Or 16 to 1, rather. So we know we want this highest mark to represent 16, which means somewhere down halfway, it's going to be 8. In between will be 12. In between here will be 4, 2, 6, 10, 14, right? Now using this, we can move on and actually start plotting our data, right? But we know the first data point exists at time 0, height 16. So up here. Our second data point is at time 1, height 8. So right about here. Our third data point is at time 2, height 4. Time 3, height 2. Time 4, height 1. So to plot our data, it would look something like this, right? Notice in this case, I didn't label each of these points because we're not talking about unique points in the sense of saying this ordered pair, this ordered pair, this ordered pair. We're talking about it in terms of data. We're saying all of this represents something, so we don't need to label each individual point. Of course, though, this is only one way of representing data. We could also represent data with bar graphs. And since we're all, I'm assuming, familiar with most of this material on bar graphs, I'm going to leave that up to y'all to check out in the book if you need a quick review of it. Instead, I'm going to say, let's imagine, I'm going to move on to distance of points, or distance between points. I'm going to say, let's imagine we have 2 points. That's what I thought. So this is the point 0, 4, and this is the point 3, 0. We want to know the distance between them. How are we going to find it? How are we going to find that distance? Okay. What's that going to look like in this case?
I believe it's like the square x, or like y2 minus y1
yes.
squared.
You're on the right track.
Yeah.
So to get us there, let's first make an observation. Notice that if we wanted to look at this without the graph, we would have something that looks like a right triangle, right? To start off with. Where the distance of the length of this leg is going to be the distance from 0, the origin, to 3, 0, right? Okay, so 3 minus 0, that distance is just going to be 3. Similarly, the length of this leg is just going to be 4 minus 0, right? Or just 4. Now from here, we can see we can apply the Pythagorean theorem, which is going to tell us that this length, d, is going to be equal to the square root of 4 squared plus 3 squared, which is going to give us 5. So we can apply the Pythagorean theorem to get to this length, but what if we didn't want to apply the Pythagorean theorem outright? What if we didn't want to go about drawing this triangle? Well, then it would help to know where this 4 and this 3 came from, right? This 4 and this 3 came from the change in our y-axis and the change in our x-axis. Okay, so some new notation here. What does this delta x mean? Anytime you see delta of anything, what it's telling you is take the new value and subtract the old value from it, right? So considering this our starting point, we could call it our old value, right? Considering this our new value, where we end along that line, then it would be this point minus this point. What I mean to say is delta x delta x is equal to where you end up at subtracting where you started from. Make sense what I mean? Similarly, delta y well, if that's the case, then this distance, it must be equal to, let me erase all this here. It must be equal to the square root delta x squared plus delta y squared. Of course, we can rewrite it as y2 minus y1, then x2 minus x1. So in our case, we already said it was 5. Having said that, some more notation here. This 2 and this 1, all it represents is a naming convention. In particular, in our case, it's telling us the order that these values occurred in. This occurred y2 after y1 occurred, right? So we can think of it as a starting point. We started at the origin, we ended up at this point 3, 0. So this would be x1, y1, this would be x2, y2. Make sense what I mean? Similarly, we could think of it along this length. What else should I note on it? That is all I've got for this. I'm going to post this as a question of the week. I'm going to post a question of the week this afternoon. And these would, for the record, since I'm going to already go ahead and post one tonight, generally questions of the week will be posted for about a day or two. I'm going to try to keep them to 2 days, just in case somebody misses class. They can see the lecture video later that next day or that evening, and then participate as well. Go. So since I'm posting that as a question of the week, was that my computer?
Yes.
Sorry, everybody. Sounds good. Cool. All right. So, with this being said, let's now imagine, instead of finding the distance between these 2 points, just erase all of this. Let's say we wanted to find the point that sits right smack in between the 2. let's say we're given this point x2, y2, and we're given another point x1, y1. And we want to find the point smack dab in between the two. How would we do that? Like, what would be the process there?
Instead of the change of x, it would be just the average.
Yeah, absolutely. So there's two different ways we can think about it, right? The first way, we can imagine that this forms another triangle. We can say, all right, if we were to send this, if we were to hold a light up here and find its shadow down here, where would this shadow be? Well, we know, looking at this, it's going to have to go through this middle point, right? Which is the average of the two x values. Similarly, if we were to hold another flashlight here and look at the shadow projected here, the same thing would occur. This would be the average of our y values, right? So in that way, we know that the midpoint between x2, y2, x1, y1 is going to be the average x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So where might this be useful? Where might y'all use this? Where would this show up possibly in business?
You can think of it like as like data, right?
Yeah. Okay. Yeah, absolutely. So let's consider an example. Let me actually use the example that I have in my book, in my notebook here. So I'm going to age myself a little bit here, but whatever. So just before an annual meeting of the Gremlins, Spike realizes he forgot the scare count for 1984, but he knows the data for 1983 and for 1985. In 1983, the scare count was 0. In 1985, the scare count was 300,000. So he decides that he's going to use a midpoint theorem, or the midpoint between these two, to approximate what the 1984 data is. What I mean to say is Spike's doing this. This is 1983, 1984, 1985. So Spike knows in 1983, nobody was scared. And in 1985, $300,000 people were scared. And he assumes that 1984 is going to be the midpoint between these two, right? So with this, you can say, all right, well, to solve this, I've got my x being 1983 plus 1984 over 2, 0, plus 300,000 over 2, which is going to give them, my bad, 1985, that's what I meant to write. Just going to give them 1984, and 150,000. So he comes back over here and he says, all right, cool. My missing data point should be right about here-ish. So this is one way we might use it. Having said that, what do we have to know in order to use this in this particular example? We have to know that the data is approximately linear. This is, like I said, Spike's assumption. It's not always the case that this is going to be true. For example, let's talk about loans, right? If we were talking about the way people owe money on loans, the way that value incurs over time, that doesn't grow linearly. So you couldn't apply this method here. But since Spike's assuming that it's approximately linear, you can apply this midpoint formula. Dope. And that means all I've got is translations. One more thing that I wanted to note on. Does anybody know what this means when you see this in a graph? Whenever a graph has this wiggle along its axis, what it means is there's a break in your axis. In this case, we skipped from 0 and went straight to 1983. We could have also used it here. It said this is about 100,000, right? All this squiggle here means is that we're skipping a bunch of values in our graph to get to the meat of the data. It's just a nice notation to keep everything linear along your axis. Because notice I could have started down here at 0 and then started at 1985, but if I did that, then 1983, 1984, and 1985 would be squished together, right? So this is just a way of helping us keep everything uniform within the axis. Make sense what I mean? Dope. Awesome. In that case, one last thing I want to talk about today. Just use a line for right now. So let's imagine we're given these 2 points, x2, y2, x1, y1. We want to translate them down so that distance is preserved between the 2 points, and y1 or x1, y1 moves to, let's say, over here. To x1 plus a, y1 plus b. Now, if distance is going to be preserved, where would x2, y2 move to? Anybody know? x2, y2 would move to the point x2 plus a, y2 plus b. these would have the same distance. What this is called is a linear translation. All we're doing is we're just translating. We're moving a point by some fixed value. We're moving a collection of points by some fixed value. This can be written in a couple of different ways. This can be written as x1, y1 plus the point AB, or we could just call it x1, y1 prime. Now, I want to make a point on this particular notation. Whenever we see ordered pairs with a prime, it means it's moved. It's been modified in some way. I want to make this point because later in the semester, we're going to use that same notation of the prime, but it will mean something else. So anytime you see ordered pairs with a prime, it just means that you translated it, that you moved it somehow. Having said that, anytime you apply this sort of a translation, this sort of a transformation, I should say, to ordered pairs, it's just a translation. You're just moving it. Because all you're doing is moving it, the distance between all the translated points will stay the same. And if we wanted to know where x middle, y middle got moved to, well, we would find the midpoint and then add our translation to it accordingly. And that would be it. Having said that, because I wasn't expecting technology to not be working today, I think I'm going to let y'all go here. What time is it? Yeah, I'm going to go ahead and let y'all go. If anybody has any questions, please stick around. Hopefully, we have all the bugs figured out Wednesday, and I think we will. Have a good one, everyone.
Hello? Could you move the camera closer to the board? I couldn't see the end part.
Okay. Yeah, give me just a second. How's that?
Better, thank you.
Awesome.
Did you see those two lines were?
Say what?
So next to the, so underneath the second in the translation, the other one, and then to the right, or I guess that would be your left maybe, and then the two lines that are next to the X and Y in the parentheses.
The prime, whatever that was.
Oh, yeah. So the prime is just a apostrophe on our ordered pair. And like I said, it's going to be a notation that we're going to use to mean something else later on in the semester. But whenever you see ordered pairs like this, it just means that you've changed to the.
The two lines mean prime is what you said?
No, just.
Or is that an equal sign?
Yep, not a problem. This is an equal sign. Equal sign. It's just this apostrophe right here that means primed or changed. Does that make sense?
Mm-hmm.
Awesome. Still me to hold it like this for a little while longer?
Are you gonna put up the daily question today or tonight or when?
When I get to my office and I get everything set up to put on YouTube, I'll post the question of the week then.
Is that just going to be labeled like on the, as an assignment or like on our Blackboard?
Oh, it'll get graded as attendance, and attendance will be part of your homework grade in the end.
But is it going to go as like an announcement and we just do what it says in the announcement, or is it going to be like in a folder where we have to go and answer?
It's a tab on the left labeled question of the week. Any other questions?
Thank
Awesome. Well, like I said, hopefully we get all of these bugs figured out next class. I wasn't thinking about the fact that my computer doesn't have a HDMI port, so with all of this figured out tomorrow, we should be good to go. Or I mean Wednesday. Everything will be a lot smoother then.
Are you gonna assign more homework like every class, or is it like you assign one assignment for the rest of the week?
So what I usually do when it comes to homework is just one assignment a week. And they'll usually be anywhere from 15 upwards of 30 problems within that week. This week it's 30 problems, but that's because it's a lot of review and I really want to make sure that we're refreshed on all of the material.
Okay.
Make sense what I mean?
Yeah.
Cool. Any other questions?
So like for homework, would it be best to start it at the end of the week when we've learned all the things that we will be discussing in the homework, or what would you say?
What I would suggest is constantly work on the homework, right? So everybody's gone, I can take this off. Awesome. What I would suggest is that you work on this continuously. You don't wait until the end of the week. You don't put it off until the end of the week. What you do is you say, all right, we just got done with a lecture. Let's log into WebAssign and see what lines up with this lecture. And let's try to tackle those. Having said that, for homework, I've given you all 100 different chances to submit your answers. So functionally speaking, unlimited, right? And the thought here is, one, I don't want y'all to try to go online and find your answers. I want y'all to work on these on your own, like to do them yourselves. And the other being that it gives you the opportunity to do exactly what I'm talking about, sitting down and being like, all right, this lecture was about ABC. I think this problem has to do with that. Let me try it. No? Okay, I have a question for next class now. A problem, whatever, I thought it was this. Can we go over it really quick? Make sense?
Yes, thank you.
So we can redo the homework until we get 100% each time, is what you're saying?
I'm saying that every question on WebAssign, you have 100 attempts of answering. And I'm contemplating doing something similar for the exams. I haven't decided yet. I'm thinking for the exams, I might limit it to 2 or 3 opportunities because typos happen. We might type the wrong thing, or we might be off by like 0.0 something, whatever. So to kind of work around that, I'm thinking about doing something similar for the exams, except it'll be limited to 3 opportunities, 2 or 3. Yeah. Any other questions? Dope.
Thank you for your time, sir.
Yeah, not a problem. If y'all have any other questions, by all means, please shoot me an email. Wednesday, we'll have some of this board stuff figured out. I'm also going to try to use the projector a little bit. So hopefully everything will be a lot easier to see. I know this is a real pain to kind of figure out. But yeah, cool. If y'all don't have any other questions, have a good one.
Bye.
Thank you.